Everybody, this is Mr. Bells coming to you. Going to give you a solution set for this Pizza Palace thing. Hopefully you'll be able to follow through on all of this stuff if we weren't able to cover it in the Google Meet. So we're going to call this key. Hopefully that's good. It says the problem involves different groups of people in a pizza place. Tommy lives 10 miles east and 5 miles north of the center of town, so we're going to go 10 miles east and 5 miles north of the center of town, and that would be at 10, 5, and that one's Tommy, so we'll go ahead and put a T there. And it says Susie lives 4 miles west, 4 miles west and 9 miles south. So we're going to put Susie down here, and that's at -4, -9. And then it says there is a Pizza Palace located directly between Tommy and Susie. So we should know that that's a midpoint. So let's go ahead and take those 2 points. It says what is the exact point that Pizza Palace is located at. Let's go here. So we got -4, -9, and we have 10, 5. And in order to be able to get that, you're looking for the midpoint. So add your x's together. That's 6 divided by 2. That's 3. And add your y's together. -9 and 5 is -4, and divide by 2 is -2. So 3, -2. So we'll go 3 and -2, and that's the Pizza Palace. I'll go ahead and put in pizza right here. That's the center of it. And it says people deliver pizza to either Tommy or Susie, but not any further than their location. So this is his delivery window right now. So it's going to go all the way out to there. In a circle, kind of like that. That's just a quick little sketch of it. So it says, what is the exact point that Pizza Palace is located at compared to the center of the town? 3, -2. How far away will Pete deliver in any direction? Well, that means I need to find the distance formula right there between those two things. So I'm going to do the distance formula from 3, -2, and I'm going to go ahead and do it to 10, 5. And again, if you're having trouble with the distance formula, you can go ahead and watch one of the separate videos on that. I'm going to do this kind of okay here. So I want to find out how far it is from 3 to 10. That's 7. And 7 squared is 49. And from -2 to 5, that's 7. 7 squared is 49. And I'm going to add those two things together, and I'm going to take the square root of it. Well, that's the square root of 98, and I know that's going to be really close to 10. I got 9.8999. So how far away will Pete deliver in any direction? Let's say 9.9 miles. I don't necessarily want to round that up to 10 just yet. Again, it was exactly, it's the square root of 98, or 9.8994949337-ish miles. So then it says, what conic section does Pete's delivery area model? Hopefully you put circle. That makes sense. Can you write an equation to model Pete's delivery area? So it should be x minus 3. Remember, if this is a positive 3 for the center, this has to be a -3 squared plus y plus 2 squared equals 98. Remember, it's the radius squared, so 9.9 squared. But remember, that was rounded, so we can just use the 98. So that's right there. Awesome. So now it says Maria lives 6 miles north and 3 miles east of the center of town. 6 miles north and 3 miles east of the center of town. That's about right there, Marie. And this isn't a perfectly drawn circle, so I'm hoping these points are kind of okay on here. It says Paul lives 5 miles south and 7 miles west. 5 miles south and 7 miles west. That's really close over there, Paul, because I don't know, again, how accurate my circle is in terms of this thing. And then it says Angie lives 3 miles north, 3 miles north, and then 10 miles west of the center of town. Good deal. So that's Angie. So you got to make sure you get your north, south, east, and west all correct as we go through these. And it says, will Pete deliver to Marie? Will Pete deliver to Paul? Will Pete deliver to Angie? Well, what we said is in class, let's go ahead and put those points in. So 6 miles north and 3 miles east, that's a -3, 6. And 5 miles south, that's a -5 for the y, and 7 miles west, sorry, that's a positive 3 east, that way. And this is 5 miles south, that's a -5, 7 miles west, so -7, -5, that would be Paul. And then Angie is a -10, 3. So what we're going to do is we're going to plug all of these things in and find out what their values are, right? We said if they're less than 98, then it's inside the circle and they will deliver. If it is 98, it's on the circle and they will deliver. And if it's bigger than 98, then that's outside the circle and they won't deliver. Okay, so here we go. Plug in the 3 and the 6 into this equation. Well, that's 3 minus 3 is 0. 6 plus 2 is 8. 8 squared is 64. So this one's 64. So that's a yes inside the circle range. -7, -5, 7, -7, and -3 is -10 squared is 100. -5 plus 2 is -3 squared is 9. That's 109. So that's a no. That's outside the circle. And even looks like it on my thing, but again, I wasn't drawn perfectly to scale as I went around here. Now let's try this one, -10, 3. So -10 and -3 is -13. That's 169. And then 3 plus 2 is 5. And 5 squared is 25. And 169 plus 25 is 194. And that's too big, so no pizza for Angie either. So hopefully this has gone pretty well for you guys right now, and you follow through on everything that I've just done. So as Pete has decided he wants to build in a new location, he realized that Tommy is not that good of a customer and would like to be more centrally located to the other 4 people mentioned. Where should Pete build his new pizza palace? Okay, so we're going to get rid of Tommy, right? So we're going to kind of scratch Tommy out over here. And we're going to look at this stuff and go, I wonder where I should put it if these locations are the 4 main locations. So we're probably looking at building someplace that's kind of in the middle of it. And I don't care where you put it. It doesn't really matter to me, but I would probably put it somewhere around like right in here. Okay. So I'm going to reference it based on this location right there, and that location is going to be at -3, -1. Now, if we had a lot more time, we could do some really advanced math and actually find the point that is centrally located between those other 4 points. But we're just going to go with here. We're going to choose that one. So now it says, write an equation that would model Pete's delivery area from the new location if he won't drive more than 12 miles. Well, that should be pretty easy. So that's x plus 3 squared, because again, we wanted to put his new location at -3, so we use plus 3, plus y plus 1 squared equals, and if that's 12 miles, we know that this number is 144. And then write an equation that would model Pete's delivery area from the new location if he wants to include Tommy in his new delivery area, but not any further than Tommy. Well, same thing goes, x plus 3 quantity squared plus y plus 1 quantity squared. We're not moving our business, we're just moving our delivery range. So we need to find the distance from his new place, which was at -3, -1, to Tommy's original place right over here at 10.5. 10.5, and we need to put that number in there. So from -3 to 10 is 13, that's 169. From -1 to 5 is 6, that's 36. And 169 plus 36 is 205. Remember, these are my answers. They don't have to be your answers. Hopefully this makes sense. Again, the purpose of this application problem is to understand equations of circles, understand how centers of circles work and radiuses of circles work, to practice the midpoint and the distance formula, and then to give a little application, because who doesn't like pizza? So again, that is Mr. Bells. Hopefully that was beneficial to you. Stay on top of the information. Make sure that you're really good with how to use the distance formula, midpoint formula, and all that other stuff. Awesome. We will talk to you later.